Hello, everyone. It's Mr. Hine, and we are now talking about exponential patterns in this lesson here. We got a little preview of it previously with the bunny problem, but here is going to be two examples that hopefully cement this. Now, exponential is a new word, and that is a word that you hopefully understand after this week. Now, recall before I start talking about this, so recall that previously we learned, and what you spend most of your previous year, by 8th grade, talking about, is you learn what linear patterns are. And linear patterns are patterns that change by, a constant, like +2, +2, +2, right? They usually change by some sort of constant addition. And notice addition / subtraction, they're the same things because you could always write a minus as plus and negative. So those are the same. So we've looked at linear patterns, or when things change by the same amount by adding. Now, what's an exponential pattern? So here's a current problem, and it's different than your classwork problem because I don't want to just tell you how to do all that. So again, note this is different than your work. But similar. So Velma and Stanley are currently sick, and each day a person infects 3 additional people. All right. So let's make sense of this in a table, day and people sick, and let's explore this pattern. So we know that on day 0, there's 2 people currently sick, Velma and Stanley. Okay. Now, each day a person infects 3 additional people. So let's draw a picture of this. So day 0, there's 2 people that are sick. Well, on day 1, each person is going to infect 3 people. So after 1 day, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 people. And then day 2, right, now we have those 8 people, so I'm going to redraw those 8 people. And each person infects 3 additional people, so they'll infect 3 more. 1, 2, 3. This person will infect 3 more. This person will infect 3 more. This person will infect 3 more. This person will infect 3 more, as will this one, here, and here. And you can see how many people it's added up. Well, I know that there's 8 previously that I circled, and we have 9, 10, 11, 12, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 30, 31, 32. So now there's 32 people. And notice how quickly that spread from just 2 people to 32 in just 2 days. But what's the pattern here is you might be thinking, okay, is it addition? +6? Well, +6 doesn't work because 8 plus 6 isn't 32. And the trick here is the pattern's not actually addition. The pattern is multiplication. Here it's timesing by 4. And you can see that maybe from a picture here, when you have one person, they infect 3, well, that one person, it quadruples in size from 1 to 4. There's 4 sets of 1 now, a different way to think about it. And that is the pattern here, is this will continue to times by 4, moving down this table as far as we need to go. Okay. Now, notice, so what is an exponential pattern? Exponential pattern is a pattern with multiplication. And with multiplication, it grows much quicker. Now, if we look at this from a graph, to show you what a graph looks like. So remember that linear patterns were just a straight line, right? It had a constant slope. Now here, if we were to graph this, you have 0, 2, 1, 8, 32. What the graph will look like is something like this. The graph starts slow, and if you connect the points, and yours should be more accurate. So I just want to emphasize yours should be accurate. Mine is a sketch. This is a sketch. Okay. But notice the difference in the graph. Linear graphs are a straight line. Exponential graphs, when we have timesing by 4, it starts slow and then it shoots up. Starts slow and then it accelerates or, shoots up quickly. Accelerates, however you want to refer to it. But that's the idea with exponential patterns is it starts slow and then all of a sudden out of nowhere, whoa, there it goes, out of control. All right. And the equation here, what's the equation of exponentials? So remember with linear patterns, the equation was y equals mx plus b, or I even switched it to y equals b plus mx, where it's like, what's your starting value? And then your rate, where we are adding some number, n. Well, these problems, it's the same idea. We need, what's our starting value? We started at 2. But what's the pattern here? Notice with linears, we were adding a number. Well, we're not adding that. Now we're timesing by 4. So it's going to be timesing by 4. How many times? Well, that depends on what you want. 2 times 4 to the power of x. And there's the equation there of exponentials, where that first number is your start at day 0. And then the times 4 to the x, well, that's your we call that the multiplier. And the idea there is, if you wanted the 4th day, well, from your starting value, you have to multiply by 4 times. If you wanted the 5th day, from 2, you'd have to multiply by 4 5 times. And remember, with powers, that's repeated multiplication. That's why powers work here. All right, so this right here, when it's growing, this is called exponential growth. All right? This is exponential growth, growing up. Now look at this example here, example 2. Now say we have $100 and you lose half your money monthly due to a debt that maybe I owe someone. That was the deal that we signed. So in month 0, I had $100. And 1 month later, I have half of that amount, which would be 50. Another month, I'd have 25. The third month, I'd have $12.50, and so forth. So what's the pattern here, right? It's a half. But what is a half is you can think about that as timesing by 1/2, right? And notice, some of you might also say, hey, I can divide by 2, and that works. Well, remember that dividing by 2 is the same as timesing by 1/2. That's the same thing in that. If you divide by 2, when you say dividing by 2, where you're saying what's dividing by 2, and you usually say like 1 whole is dividing by 2. So you get 1/2 of something. Okay. Now if we keep going here all the way down, like 4, it's going to be $6.25. 5th month, I'll only have $3.12. I know it's even smaller than that, but that's fine. I actually made a mistake there. That should be 125. Now, if we look at a graph of this, well, let's write the equation. So the equation here, practicing what we just talked about, is what's the starting value in the multiplier, or the pattern, multiplier/pattern, that's fine, is it starts at 100, so it'd be 100, and then it's timesing by 1/2, so it'd be 1/2 to the x. Now, just be careful. Notice how it's 1/2 and not dividing by 2, because if you tried doing this, that doesn't really make sense. Dividing by 2 to the x. You usually would write, this is a little bit more advanced, but you could write that as 2 to the negative x. Negative exponents is how many times you're dividing something, while positive exponents is how many times you're multiplying something. So saying 2 to the negative x is the same as dividing by 2, or 1/2. That's the same as this. But if you just put dividing by 2 to the x, that's not quite right. Anyway, so that's the equation. And then a graph here to show you this last part that's new is you started at 100, which is somewhere up here. Then we had half of that amount, then half of that amount, then half of that amount, then half of that. And notice, if we keep getting a half of something, like say I gave you an apple and I said, keep cutting an apple in half for me. Well, theoretically, you should always be able to cut something in half. You can't cut something in half and end up with nothing. You should always be able to cut something in half. So the idea is if we keep cutting in half, will we ever get to 0? And theoretically, no, you won't. It actually gets closer and closer to 0, but will never touch 0. Closer and closer to 0, but never touch. And that right there is a concept in math called, where this line here is 0, I highlight it in red, the fact that it's getting closer and closer to it, this is called an asymptote. And an asymptote is that idea there. You get close, but never touch. Something new. So quite a bit of new stuff in this. As you do your lesson yourself, you'll be exploring these concepts yourself, where the first one's exponential growth because it's growing, and here how it's getting closer and closer to 0, this was actually exponential decay. Okay. A lot going on here, but I bet you if you do it yourself, it'll make more sense to you. It's always a little bit different when you take it on yourself versus just watching something. All right. Good luck with that lesson. Let your teachers know if you need some help. All right. Bye-bye.